Determine the limit as x approaches positive infinity of cosine of x divided by x squared plus 1. So the limit as x approaches positive infinity of cosine of x divided by x squared plus 1. The first thing to do is plug a positive infinity in for each of the x's. This will give the cosine of positive infinity divided by positive infinity squared is positive infinity plus 1 is still positive infinity. The cosine of positive infinity is indeterminate due to oscillation, but it will remain finite somewhere between -1 and +1 because of cosine. And since it's being divided by an infinity, this will have a definite limit and can be determined using the squeeze theorem. Starting with the cosine of x, which sits somewhere between -1 and +1, the function we want to find the limit for is cosine of x divided by x squared plus 1. So we will now divide each of these by x squared plus 1, and the inequality will still hold true. And we can take the limit as x approaches infinity for each of these, and it will still hold true. And this middle one will be the limit we're attempting to determine. Starting with the leftmost limit, first thing to do is try plugging a positive infinity in for each of the x's. Positive infinity squared is positive infinity. Plus 1 is positive infinity. Each term that is a constant divided by a positive infinity will go to 0 as x approaches the positive infinity. So the result of that limit is 0. The middle limit we do not know. It's indeterminate due to the cosine of positive infinity, so we'll leave it alone. The rightmost limit, plugging positive infinity in for each of the x's, positive infinity squared is positive infinity, plus 1 is positive infinity. Each term that's a constant divided by positive infinity will go to 0 as x approaches the positive infinity, so that result is also 0. We have the middle limit as being squeezed between 0 and 0, and therefore the middle limit as x approaches positive infinity of cosine of x divided by x squared plus 1 has to equal 0 due to the squeeze theorem, and we have determined the limit is given.